Hello and welcome to this demo of Opni, a multi-cluster, multi-tenant observability platform that comes with AIOps capabilities. This demo includes only the logging portion, so please check out our website at opni.io to watch a full demo of monitoring.
So first thing we need to do is set up our central cluster where the main Opni services, the centralized logging and the centralized metrics are going to live. To do that, I've got a EKS cluster here that's been freshly set up. All that we've done is installed Cert Manager, which is a prerequisite for Opni, and we've also installed an ingress controller so we can expose some services via an ingress. The first thing we're going to do is going to go into the Apps and Marketplace section, and we're going to add the Opni Helm chart repository. So the details of the Helm chart repository are in the Opni documentation under the logging setup. So we're going to go ahead and create a repository. We'll call it Opni. It's a Git repository containing a Helm chart, so we need to select that option, and then we can copy and paste the details here. So the Git repo URL is the Opni Git repo URL, and the branch to use is charts repo. So we can copy and paste that in there, and we can create that. So once that's refreshed, we should see the Opni charts available under the charts repo. So if we disable the rest, we can see that we've got three charts here. We've got Opni, which is for the central cluster, the Opni agent, which is for bootstrapping downstream clusters, and then Opni Prometheus CRDs. So this is another prerequisite for Opni. We need to install the Prometheus CRDs for the Opni monitoring system to work. So we'll go ahead and do that now. It's just a simple case of checking install. And so that will go ahead and install the Opni, the Prometheus CRDs. So once that's done, we will go ahead and install the Opni Central Cluster. So go to Charts, and we'll select Opni, and we'll select Install. So the namespace we're going to want to install that into is the Opni Cluster System namespace. And so it is a requirement that it gets installed into that namespace. Currently there are some hard-coded options that point to that. In the future this will be configurable. So here we have a bunch of options. So the other thing that we're going to need to set up is we're going to need to expose Opni a number of URLs. So we're going to need the gateway. This is the main Opni API that accepts metrics and accepts authentication for downstream clusters. We're going to need to expose Grafana for monitoring if we want to view the graphs in that. And we're also going to need to expose an OpenSearch URL. So this is for logging to be indexed to. So first off, we're just going to do this one. So we'll select gateway. And to expose this, we're just going to use a load balancer type service. So that will, in the EKS system, expose it with a classic load balancer. For auth settings, we're just going to use the gateway auth. So we're going to choose to enable monitoring. So as mentioned, we're going to need to choose a Grafana hostname. And for the purposes of the demo, we're just going to use a local file system backend for Grafana. We're also going to choose to enable logging. And as mentioned, we need the OpenSearch external URL. And then we need to choose whether we want to enable persistent storage for OpenSearch. So we're going to do that and select the default storage class. And then we can choose whether we want to expose the OpenSearch data nodes. It's recommended that you index directly to data nodes, so I'm going to choose to do this, and we're just going to leave this as a cluster IP, and we will expose the OpenSearch with an ingress later on in the demo. And then finally, we're going to choose to enable the AI services. The final thing we need to do for this demo is to change the Opni tag. So this contains features that haven't been released yet. They will be released in the 0.4.2 release that is coming imminently. So for the meantime, we're just going to switch to the main tag for Opni. And then we can go ahead and hit install. At which point it will install all of these services. So once that's complete, we can see here that it's installed all the services. We can go in and have a look at the workloads that we are getting. So it installs Cortex, Grafana, and then the Opni Manager and Opni Gateway. Under logging, it will also install some Opni nodes, Opni Master. It installs NATs for the AI services, and a whole bunch of stuff here. Under service discovery, we can see it creates a bunch of services, including some that we set as load balancer. So we're going to need to go ahead and create those DNS records that point to those load balancer services. So we can go ahead and do that now. So an important thing to point out here is that we currently have two Opni services that are currently labeled Opni monitoring. Now these are the Opni gateway services. The internal one includes the management UI and the management API. This should not be exposed to the internet. This is only used for a custom cluster administrator to go in and manage the Opni downstream clusters. The other one is the external one, Opni monitoring, and it has a NoAuth endpoint. That was the NoAuth that we selected in the install process, and it has the gateway port, which is 8080. So this is the load balancer service that we're going to expose with our DNS records. Now that we have exposed all of our services, we can continue on with looking at the details of Opni. So we have exposed OpenSearch, Grafana, and OpenSearch dashboards using a ingress, and we've got DNS records for those. So let's take a look at OpenSearch dashboards. So we can see here that we've got an index pattern set up, and we've got a dashboard, and we've also got an Opni plugin. But currently we are getting no data into that. So to do so, we will need to bootstrap a downstream cluster. So the next thing we need to do is make sure that we have a token to bootstrap our downstream cluster. So to do that, we need to access the Opni gateway. We haven't exposed this because, as I mentioned before, this is an internal service which should not be exposed. So to get access to this service, we're going to just use kubectl to create a port forward to it. Right, so we've now got our port forward set up, and we've gone to localhost on port 1280, which is the default port for the Opni monitoring UI. And here is where we can manage all of our downstream clusters. So the first thing we're going to do is create a bootstrap token. So this token is used for the initial authentication between the downstream cluster and the Opni gateway before it then sets up secure communication. So we're going to create a token. We can give it an optional time to live, and this token can be used for as many clusters as you want. So once it's expired, it's no longer usable, but while it is valid, we can use it to bootstrap any number of clusters. So we're going to create that here. So let's go back to our Opni UI. So the next thing we're going to do is go to our downstream cluster that we want to bootstrap. Once again, this is a fresh cluster, and all that's got installed is Cert Manager. So again, we're going to install the Opni repo into here. And copy and paste our repo URL. And add that in. So this time we're going to select the Opni agent to install. And we're just going to put it in Opni system. So we can see here that we have a bunch of required information. So the first piece of that is the Bootstrap token. So we can copy and paste that here. Now if we go to metrics or logging, we can see that we have this option to disable gateway TLS security. If we choose not to disable that, we're going to need to enable certificate pinning. So to do that, we'll need to get the certificate pin. If we go to create clusters, and we add either one of these with this option here, we can see that we've got this pin option here. So that everything after the equals is what we're going to need to put into our UI in Rancher. So I've extracted that information and we'll put it in there. And then the last piece of information that we need is the gateway URL. So let's put that in now. That was the option that we chose when we installed Opni in the central cluster. So it's HTTPS and it's the gateway URL. And by default it lives on port 8080. So we'll put that in there. Now let's go through and install the Prometheus operator so we can get some metrics and install the metrics agent. And we'll also install the logging agent. We don't need to disable any of the TLS security. And because this is an RKE cluster, we'll select the RKE Kubernetes distribution. And we will go through and install that now. And now we can see that it's successfully installed, and as part of that install it has created a bunch of pods here. Now these are the automatic configuration for both metrics shipping and log shipping to our centralized cluster. So if we go to our OpenSearch dashboards, we should see that we now have logs there. So if we go to Discover and we log back in, and we can now see that there are logs coming through into our system. And if we go to the Opni, we can see here that it's not detected any anomalous logs so far, but it has seen logs from the various Kubernetes control plane components. Likewise, we can also go to our log anomaly dashboard and get another breakdown of the anomalies here. So these are roughly analogous. I'm now going to inject a fault into the Kubernetes control plane, and then we can review how Opni handles that failure. We've now injected a fault, so let's head to the Opni insights and see if there's any options or anything that's showing up here. So looking at our timeline here, we can now see that we've had a huge spike in anomalies in just a little wee while. And if we have a look at these, we can see the majority of these errors are from the Kube API server and from the etcd server. So looking at this, it's telling me that it is having problems connecting to an etcd node, and that was indeed the error that has been injected. We have stopped an etcd node, and we can see here that Opni has detected those. If we look at our overall logs, we can see here that we have 3,993 hits. And if we go to our dashboard, we can see that Opni has reduced that by around about 200. So it's only showing us the messages that are producing the error. And we can see here, looking again at our Opni insights, that a large number of these are coming from API server and etcd. So we can see that we're getting 3,000, about 4,000 anomalous logs from the API server and only 55 normal. Likewise with etcd, we can see that we're getting 100 anomalous logs and only 121 normal. So that will give us a pretty good indication of where the problem is. And if we click into one of these, it will take us to the discovery page so we can look directly at these logs in more detail.